Goal 1 is to use the momentum formula to calculate the momentum, and goal 2 is to rank objects from highest to lowest momentum. So if we want to try to find the momentum of a 6.25 kilogram ball rolling at 7.5 meters per second, you're going to need to have your calculator. And this is our mass, and this is the velocity of the bowling ball. And we know the equation for momentum, P equals mass times velocity. So P equals 6.25 kilograms times 7.5 meters per second. You end up with 46.9 kilograms times meters per second. All right, next what we're going to do is we're going to put these in order from greatest to least. So in order to do that, we need to know the momentums of all of them. So for all of these, what we're going to do is we're going to multiply. So we have 22 kilograms times 10 meters per second. We have 37 kilograms times 8 meters per second. And then we have 16 kilograms times 100 meters per second. So you go to your calculator. If you can see this in here. Okay, go to our calculator. We have 22 times 10. 37 times 8. And 16 times 100. And then the units for all of these, they're all in kilograms times meters per second. All right. So the order is going to be from greatest. Well, the greatest momentum is 1600. That's object C comes first. And then 296 is B. And then A. So this is the greatest to the least. And then for the last one, they want to know the momentum of a 360,000 kilogram passenger moving on a runway at 1.5 meters per second. So again, P equals mass times velocity. So 36,000 kilograms times 1.5 meters per second. You go to your calculator, type that guy in. And you get 540,000 kilograms times meters per second. Goal 3 is to quantify how changes in mass and velocity affect momentum. Okay, so let's take a look at this. We have a momentum equals mass times velocity. Okay, well, the momentum of an object then has to depend on these two things, mass and velocity. In order to have momentum, you have to have both mass and velocity. The momentum of an object is 0 when the object is not moving or the object has no mass. Now, if the object has no mass, then we would assume that that object does not exist. Therefore, the momentum of an object is 0 when the object is at rest. The momentum of a truck will be greater than the momentum of a mosquito when the truck is blank, but the momentum of a truck will be less than the momentum of a mosquito when the truck is blank. Okay, so the momentum of the truck will be greater when the truck is moving, but the momentum of a truck will be less than the momentum if the truck is at rest. So if the truck is not moving and the mosquito is, then the momentum of the truck will be 0, right? But if that truck is moving, like a mosquito is not going to be able to move anywhere near fast enough to make its momentum equal to the truck. So the minute that truck is in motion, its momentum is going to be a lot bigger than the momentum of the mosquito. All right, if two objects are moving at the same velocity, so I want you guys to take a look, if they're the same velocity, then we only need to compare the momentum with the mass. So the object with the greater mass is going to have the greater momentum. So a bigger mass means a bigger momentum. Okay, so same velocity means that mass and momentum, right, are directly proportional, and if one is greater, then the other one is greater. So if the one with the greater mass will have the greater momentum. So this works the same way. If they have the same mass, then the one with the greater momentum is going to have the greater velocity, because momentum and velocity are also directly related. So the object with the greater velocity will have the greater momentum. Okay, so the last one here, how would the momentum of an object change if its mass was cut in half and it was traveling with only half the speed? So generally, we know momentum is mass times velocity, right? But if we have a new momentum, I'll just call that P prime, it is going to have half of the mass, and it is going to have half of the speed. Okay? Well, if I pull this out, this looks like 1/2 times 1/2 times mass times velocity. But mass times velocity was my original momentum. And 1/2 times 1/2, that's 1/4. So how would the momentum change? It would be 1/4 as much. Okay? So it's going to be 1/4 as much if both of these are cut in half, because mass times velocity was our original momentum. And then what we do is we just multiply these two numbers together, and then we get 1/4 as much.